So here we go. This is kind of the big idea of the chapter. These four things. These four things are the big thing that we have in chapter 1. So we take some time in going over them. Shape. We talked about that, right? There's 3 shapes. Outliers. Outliers we'll talk about tomorrow probably. Center, we started talking about that last time. We're going to talk about that today. That's the one we're going to focus on. Spread, we'll talk about next week. Spread is the last one. We'll talk about it. Okay? So the ones we're going to focus on today is center. And we talked about it. Center is the mean or the median, right? The mean or the median. Okay. All right. So we talked about the differences between them. How you find them is different. One, you need a calculator to do. One, you don't need a calculator. You just got to put them in order. Which one's in the middle? Okay. So which do we use? Well, we talked about which do we use. We said that I used houses and salaries of professional players as examples as to which one we use. Okay, so we say the median is resistant. What does resistant mean? If something is resistant, what does that mean? Holding back, right? It's not going with what everything else is, right? It's holding back something, right? It's resistant. Like if something is water resistant, it holds back it holds back water, right? It doesn't retain water, right? Water is repelled against it, right? So resistant means holds back. Okay. So the median is resistant to outliers, extreme values, right? So what does that mean? That means it fights them off, right? Why isn't the mean resistant? Say it loud. What can change? Not the data. You're close. Not the data. Think about, yes, yeah, Ikwin. Exactly. Yeah, we use home values, right? Home values in Fresno. Most of the home values in Fresno lie somewhere between 200,000 and 500,000, right? That's where most of the home values. Let's say somebody from somewhere comes in and it's like they got a bunch of money and they're like, I want to build a home in Fresno. They build a $5 million home. What is that going to do to the average price? It's going to move it up, right? The mean always wants to go that way, right? If someone built a shack in Fresno, like here, that wouldn't really do anything because these numbers are a lot closer to the shack than they are to the $1 million home, right? So if you took out one of these farms around us, took it out of the data, the mean would go down, right? If you added one of those, the mean would go up. So the mean is kind of like this, kind of goes back and forth, right? We good? We ready? Okay. That's why the median though is resistant. The median might move a little bit, but it's not going to move as much as the mean is. Okay, so let's look at the data down here. So the first graph, what shape is that? That's pretty textbook what? What shape is that? That's pretty textbook skew right. Pretty textbook, right? It's got a nice little slope going down. Starts left, top, because the high data is on the left. Okay? So here's a question. Let's focus on this one first. Where are the extreme values here? Where are the extreme values? Okay, so you have a couple options. On the left side, in the middle, on the right side. What does extreme mean? right? To be extreme, doesn't it mean there can't be a lot of them? Otherwise, they're not extreme, right? So, like we were talking about LeBron James yesterday, he makes whatever, $50 million money. If we all made $50 million, would he be extreme? No, right? So, that being said, where are the extreme? There is. Where are the extreme? Left, middle, or outside, or the right side? Why? Yeah, you're right, John. Why to the right? Why is it? Yes. To be extreme, there has to be not very many of them, right? There has to be not very many of them. In Fresno, we have extreme heat. They should stop calling it extreme heat because we have it all the time and we have so many of them, right? It's hot, but it's not extreme, right? Um, so, but if you talk to someone from like the desert, if you talk to someone that lives like in Las Vegas, 110 to them is nothing. They got 125 like that, right? So maybe they're like, yeah, you guys all got extreme. We got extreme. Well, we don't have 125. Feels like 125, but we don't have it, right? So the extreme means there's not that many of them. So these are the extremes. The extremes are going to be where there's not very many of them. Okay? So if these are the extreme in red that I circled, what is going to be bigger, the mean or the median?
Median.
Why the median?
Mostly because, like you said, median is like off to the right, and then beginning data is like small amounts of data, but in the left row part, the y-axis per se is measured.
Yeah.
But then the right side means like a larger amount.
Okay. So $5 million, right? Again, which way did we say the mean's going to go if I add a $5 million home? This is the extreme, right? Kind of like this. The extremes to the far right. So I add a $5 million home. Which way is the mean going to go? It's going to chase the extreme, right? It always chases the extreme. So which one is bigger? The median's like, nah, I'm staying still. I'm not moving. The mean's like, oh, I want the extreme. So which one's going to be bigger, the mean or the median? The mean. The mean is going to be bigger because it goes towards the extremes. Wherever the extremes are, that is where greater than, right? That means greater than. That's where I want to go. Mean always wants to grab the extremes. So wherever the average is, it's going to be to the right of where the middle number is. Okay? So how about the opposite? This one is skew left, right? Skew left. Where is the extremes? No, where is the extremes on the graph? Very far left. Same place, same kind of idea, just, they were over there last time, now they're on the other side. So where does the mean want to go? The mean wants to go, it wants to go to the extremes. That's over there. So if the mean is going this way and the median's staying still, who's going to be bigger? The median this time. The median this time. Because the mean's running this way now. If the mean is running this way and the median's staying still, left means lower, right? Yes, the median, not exactly. The median might move a little bit, but when I say a little bit, I mean like that. Whereas the mean, right? This is like going up to the Bay Area, going up to San Francisco, going up to San Jose. San Jose, California, you guys have probably all been to San Jose. San Jose, California has one of the most expensive places to live in the world. Just right up, not too far away. 2 hours, 3 hours, you can be there. San Jose has one of the most expensive places to live, right? The average or the median price there to buy a house for a regular house like we all live in, about $1.5 million. The house you live in right now, if you could pick it up and move it to San Jose, it would be worth at least $1.5 million. Okay? So let's say we're in San Jose, right? Now, the extreme is not here. And I go build my shack. I find a little plot of land and I go build my shack in San Jose. I would be over here, right? In the extreme. I'd be extreme that time, right? The $5 million guy in Fresno is no longer the extreme in San Jose. He's somewhere over here in the middle, probably, right? So it just depends on what the extreme is, right? Here, the extreme is my little shack, my little shack that's worth barely nothing, right? Over here is where everyone's at, right? So I would be an extreme. So if I went to go, that wouldn't be good for people to San Jose. They don't want me there. Because if I built my little shack there, guess what happens to their average home price? Goes down, right? Goes down, right? That's why home values in Fresno have gone up since before, right before the pandemic. They've gone up like way up because more of these people over here are moving to Fresno.
So what you're saying is people should start building shacks.
To offset it?
Yeah.
Yeah. These over here are not so, I mean, in Fresno, we're kind of like this, right? Most of our homes are in the middle somewhere here. Well, people from San Jose are coming down and saying, hey, I can build a mansion in Fresno. Because you know what? I can work at home. So I don't need to be going to the office every day. So these guys over here are kind of growing a little bit. Not enough to say they're still extreme. But what that does is causes all the other homes to go up in value, which is good if you own a house. Like me, I own a house. So my house went up a lot since I bought it. But I have friends who are trying to buy a house right now. And they're like, I hate it because a house I could have gotten for 300,000 now costs 500,000 in Fresno, right? So it's good and bad sometimes. It's good and bad sometimes. Just depends. That's what causes things to go up and down. Okay. All right. So one big thing, the mean wants the extremes. To be extreme, there can't be a lot of them. Okay. How about this? No, just like we're not specific here. We're just saying where is the lower bars? To the right, to the left, right? These guys out here. These guys out here. It's just kind of in general, not specific. 0 would be over here. So this one, it would be considered not an extreme. This one, it would be considered an extreme. Okay. So let's look at this picture real quick. Let me get my notes because there's one picture we haven't talked about. And where's the extremes there? Low side and where? High side, right? So where does the mean go? The mean is attracted to extremes, right? Well, aren't there extremes over here? And aren't there extremes over here? So where's the mean go? Stays right in the middle. They both balance each other out. So in these guys, the mean and the median's right in the middle. Mean's got nowhere to go. It's like I want to go somewhere, but I can't go over here. But then I got to go over here. But then I got to go. So it just winds up in the middle. Okay. But this guy right here, there's only one extreme's out here. So the mean goes, I want to go out here. I want to go to the right. Opposite over here. Okay. Chapter 2, all we talk about is guys that look like that. And we'll get more into it about like actual like specific and stuff like that. Okay. All right. So what I want you to do now is I want you to answer these questions here. Find the following numerical summaries: the mean and the median, And then roughly what shape does the data set have? Don't graph it. Tell me based off your data, which one do you think it is? Because we already know what shape it is, right? You guys have graphed this one already. We graphed this one a couple days ago. Okay, so I want you to answer those two questions. Use your calculator, answer the question. One of them you can use your calculator. The median and calculators are really not going to help because it's not calculations. Okay, so I'll give you about 3-4 minutes. Okay, so I'm going to show you guys a shortcut that you can use. I don't know if it's a shortcut, but it's a different way of doing it. You can do it by hand. So a lot of you use the calculator to do average. That's fine. This is another way to do it. And I forgot the calculator will actually do median for you too if you do average. It'll do it at the same time. So first thing you got to do is put all the numbers in. Don't do it right now because just for next time. You put all the numbers in L1. How do I get to L1? Remind me, how do I get to L1? What's the first button I push? After on. Stat, there you go. Stat. Oh, I'm not there. What else do I push? Edit, right? Yeah, edit, edit. And there you are. Okay. So I put all the numbers in here. Well, you guys are doing that. So this is an option. So this, so if you go back to stat, now instead of edit, we're going to go over to calc. We're going to go over one to calc. And then you're going to click on number one var stats, var stats. And then you got to tell it, well, where is your list? My list is in L1. So I got to go second one, that's L1. It's got a little blue L1 above it. Frequency list, don't worry about. We only use that once the whole year. We only change this once the whole year, and it's not until chapter like 6. So just leave it blank. Calculate. Here are your numbers. The first one, the very, very top one, the X with the little line over it, it's called X bar because it's X and it's got a bar over it. That's the mean. 42.5. Okay. The number right below it is a Greek letter. Does anyone know what letter that is? Does anyone know what Greek letter the second one is right below X bar? This guy right here. It's called sigma. What does it sigma do in math? Anytime you see that in math, what does it mean you're going to do? Summation. Yeah, summation notation. It means you're going to add up a bunch of stuff. So with this 1360, it took every number in the list and added it up. Do I need that? No, but it's there. The next one, sigma x squared. It squared every number in my list and added them up. Again, do I need that? No, but it's there. The next two are standard deviation. Don't worry about. N equals 32. What does that mean? Yes, how many numbers in my set? 32 numbers in my set. Minimum, the lowest number is 16. MED, see the MED right there? That's the median. Now, I have a question. All my numbers were whole. Why is the median, if I'm looking for the middle number and all the numbers are whole, why is the median a decimal? Yeah, Gershon? Yeah, so there were two numbers in the middle. You added them up and divide by 2 and you get 40 and a half. Yeah. If there was only one number in the middle, then you just use that number. But if there's two numbers, you use that number. Okay. All right. So next time we do this, trust me, there will be a next time. You can use that trick, or you can. It doesn't matter to me. It's a quicker way of doing it. You can do the mean and the median all at once, one shot. Okay, so 42.8.
Yeah, 42.2.
Let me check my numbers. I think that's 42.5. Did anyone get 42.5? Okay. Sorry. But good news is you won't ever get it wrong again because you know that trick. And that trick will always give you, because sometimes when you're putting them in, you put them in fast and something happens. So, but this trick, put them all on the list. Don't have to worry about that. Okay, so we have 42.5 and 40.5. How are we going to use that to determine shape? We don't have a graph, so I can't match it with one of my shapes. But Remy, how can we do it? What about the graph? If we had a graph, we could answer this question, right? But we don't have a graph, Jordan. Exactly. Yeah. Because where does the mean always want to go? To the extremes. Yeah, Jordan, say it again. Right? It's always drawn to the extremes. Now, is that a lot bigger than the median? No. So it's just a little bit skew right. It's probably not that bad, but if I would have to classify it, I would say skew right. And I would say exactly for the reason Jordan just said. If the mean is bigger than the median, it's skew right because the mean is attracted to the extreme values. Okay. So some people say, well, how much bigger does it need to be? It doesn't matter. If it's bigger, that means there's going to be some skewness to it. Is it going to be crazy skew? No. But remember, it's the best. Remember, the one that best fits, right? The one that best fits the data. Symmetric, for it to be symmetric, the mean and the median have to be pretty close together. Pretty close together. Relatively close. I mean, it just depends on what data you're looking at. Like if my mean was 4,000 and my median, if this was 4,250 and the median was 4,050, relatively speaking, that's not very far off. So it just depends. But here is where you have some leeway. Again, there's some leeway. If you explain to me why your answer is, like if you said what Jordan said, the mean is a little bit bigger than the median, so that means it's going to be skew right because the mean is attracted to extreme values. I'd give you full credit. Let's say you said, well, you know what? That's not too far off. That's only 2 points. So they're pretty symmetric because the mean and the median are pretty much the same number. I'd give you full credit. Because it's kind of the eye of the beholder. If you think 2 is off, is far enough distance, then yeah. Now, if you would have said the opposite, if you would have said 42, the mean is 42.5, the median is 40.5, I think it's skew left. That's obviously wrong. But if you said they're about the same, so it's approximately symmetrical, full credit. If you said, like Jordan said, that's the way I was initially thinking, what Jordan was thinking. 42.5 is a little bit bigger than 40.5, so that means the mean is a little bit bigger, so that means it's skew right. 100%. It's how you express yourself. It's not the answer I'm looking for. It's how you express yourself. Obviously, there's wrong answers, but in terms of right answers, there's a couple. There's a couple. Okay? Just make sure you explain yourself and explain yourself correctly. That's the biggest thing. Communication. You got to be able to communicate that. Okay? All right, let's see. Okay, so last thing we're going to do is we're talking about 5 number summaries, then we'll be done. 5 number summaries. I don't think we'll get to the box plot. We're just going to do the 5 number summaries. Okay, box plot is the last graph that we're going to see this year. Not the last graph we're going to see this year, but the last graph we're going to do in chapter 1. Okay? 5 number summary. 5 number summary are 5 things. It's up here. One of them is the minimum. That's 1. Quartile 1. The median. Quartile 3. The maximum. And then outliers we'll talk about tomorrow. Don't worry about outliers today. Okay? So a few years ago, pre-COVID, I measured everyone's height in statistics class. I had a class like this. I had everyone measure their heights in inches, and I put it on the board. Okay, I can't remember what year. This is pre-COVID though. Okay, so so for if I'm 5 feet tall, how many inches am I? 60, right? So this person's 60, 5 feet. Anything below that's less than 5 feet. Okay. How tall is 80? 80 is on here too, right? How tall is 80? About 6'6", what? 6'6"? Okay, yeah, 6'6", pretty tall person, right? How short is 44? Pretty short, right? Pretty short, right? Right? Yeah, it's pretty small. Okay, it's pretty small. Um, but yeah, that's how I got the numbers. Okay. Oh, off the top of my head, I can't remember, but I can't remember who it was. But yeah, these numbers are real. Um, yeah, I can't remember. Even if I could, I would tell you the name. But off the top of my head, I can't remember if it was a boy or girl. Yeah, they were. Yeah. Okay. Um, so to find things like the median, what do we have to do first? We could do it in the calculator. We could do it in the calculator, but let's do this one by hand. In terms of doing it by hand, what would we have to do first? Yeah, least to greatest. Is that what you say, Alexis? What were you saying? Oh, I thought you had your hand up. Oh, oh, okay. They took your answer. Yes, that's what we need to do. Okay. So let's put them in order from least to greatest. This is probably the last time you'll do it. If you have it, like if you have a calculator, you can do it a lot easier. But I want to show you by hand once to see how it works. Okay, because you got to know minimum and maximum are pretty self-explanatory. The minimum is the lowest, maximum is the highest. Median, you guys know how to do. But quartile 1 and quartile 3, they won't make sense unless we actually do it by hand. So let's do this one by hand. Okay, so yes, we could do all of that on the calculator. Mm-hmm. Yes, yeah. Yeah, that's all it is. Okay, so let's put them in order. 44, 52, 55. There's a 50 in there. Missed the 50. 52, 55. Any other 50s? No. Is there a 50? 60? 60, 61, 62. I got a 63, 64, two 64s, two 65s, 66, two 67s. What else do I got? 69, 68, 69, 71, 72, 73, 74, two 74s. Nope. Wait, did I get 73? Yeah. And then 75. And then 80. So let's see, do I get them all? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, got them all. Okay, so the median. Find the median first. Cross out. There's no like quick way to do it. You just cross out until you get to the middle. It's one of the easiest things to do, but it just takes some time. Okay, I got two numbers in the middle. So what was the rule again if I got two numbers in the middle? Divide them up and divide by 2. Yep. So the median is going to be 65 and a half. Okay. Q1. Q1 is the median, but of the every number below the median. Okay, so I'm going to highlight the median. Does the median's not even on our list, right? It's not even on our list. It's a number we came up with because there was no number in the middle, right? So every number that's smaller than 65.5, we're going to do again. We're going to find the middle of that. Okay? So let me do that in a different color. So cross out that one, cross out that one, cross out that one. And I guess I got 2 again. That is called Q1. So that one's going to be 61.5 because it's in the middle. We're going to do the same thing now on the higher side. That's going to be Q3. I get 2 again. That's Q3, and that's going to be 71.5 because when you add them up, divide by 2, you get 71.5. Okay, so let's write down what I have so far. Yeah, those are the easy ones, right? The median is 65 and a half. Q1 is 61 and a half. Q3 is 71 and a half. And then what'd you say? What's the minimum? That's the smallest number. What's the maximum? 80. That's the last time you're going to have to do it by hand. After that, you can use the calculator. Okay? Now, what we're going to start tomorrow is we're going to use, that's the 5-number summary. That's called. So when they say 5-number summary, those are the 5 numbers I need. Median, maximum, minimum, Q1, Q3. We're going to use those tomorrow to make what's called the box plot. All right, nothing. No new assignment. There's only one assignment out there, and that's due tonight. So make sure you scan and upload it. What's that?